All right, so we are leading up to synthetic division, which is an easy, faster way of dividing polynomials. We're leading up to it. We're not quite there yet, but that's the topic. That's where we're heading. Division.
Wait, what did we just do last class then?
We did this. This is long division, so this is polynomial long division. So if we start off with a polynomial and we figure out, or perhaps I give you that x equals 2 is a root, then the corresponding factor is x minus 2, right? We okay with that so far?
100%.
So we're going to use x minus 2 to divide into the polynomial. So we kind of took a look at long division and remembered our long division rules from 4th grade. And we use that sort of as a model for how we're going to do polynomial long division. So we did polynomial long division. We ended up with a remainder of 0. So that told us that this result, which is called the what? Quotient. Times this part, which is called what?
Dividend.
The divisor.
The divisor. The thing that divides is the divisor. This times this is our original function. So this is our updated function that's factored now. But this is equivalent to our original f of x. So we've taken the first step toward factoring. So we're not quite done. So what do we do from here?
We are quite done.
We aren't quite done because what are the roots? What are the roots so far?
So you have to set them both to 0?
So
Oh wait, no.
can you answer based on this updated version of f of x what our roots are?
No.
I can't. This is like starting with a quadratic. Now, like what are the roots of that? Well, I have to factor it. Or
Can we factor out x or something? No.
does every term
No.
have an x? So I couldn't factor out an x. If this looked like this,
Yeah.
then absolutely I could factor out an x. That should have been a squared. Yeah, so I could do it depending on what I have, but in this case I don't have anything that I can factor out. So what I'm trying to answer is what are the roots. Am I ready to answer what the roots are yet?
Absolutely not.
No.
Can I answer what any of the roots are?
Yes.
One of them.
Which
X
one?
minus 2 equals 0, which is 2.
So x equals 2. I'm going to have that as one of my roots. That was in the problem to begin with. So I'm making progress, but I'm not there yet. So what do I need to do?
Factor.
I need a factor or solve it in some other way. So tell me exactly what I need to do here. I think this is from another class.
Something.
That looks terrifying. I don't want to do that.
Yeah.
I'm already cooked enough in this class without that.
So what do I need to do here, Matt?
Well, I mean, obviously you got to do a quadratic equation.
I could do the quadratic equation.
Or you could complete the square.
I don't need to complete the square.
Never mind, you shouldn't complete the square.
Synthetic division?
We
No.
already did that. Wait, no we didn't.
Synthetic
Say it again, Patrick.
No.
I didn't say anything.
Factor by grouping.
So factor by grouping is usually what I do when I have 4 terms. Would you agree?
Yeah.
So let's just factor. So can I see
What?
like what would the choices be if I were to factor
3x and 2x.
3 and 2
Minus.
or
6 and 1.
or 6 and 1?
Who just said
6,
6, 7? I said 6x. Someone said 6, 7.
It's not like 6, 7.
Is Finn getting this recording?
Yeah.
Oh no.
So in 15 years from now, this recording will still be on YouTube. So you'll be able to like
I hope
show
everybody
your
watches it.
grandchildren.
6, 7.
Yeah.
Stop.
It's for Finn. We really gotta.
That was such a.
Do I have any ideas on how this
Oh, yeah.
might factor?
I think we should do 6x and x because 3 and 2 can't get to 7. You know what I'm saying?
3 and 2 need to get to 6x squared.
Well, yeah,
but then
also
these
that-
things, this outer and inner need to get to -7,
Yeah, it's
and then the
impossible.
last
Wait, what about
needs. Well, you,
wait, it's just -2 and -1. No?
where's -2?
The 3x?
-2 and -1, because they need to multiply together to give +2, right?
Yeah, and then there'd be
And then they
4.
add together to give what?
-4, -3, -7x.
I feel like we should just start calling Matt Finn.
Why?
Because I feel like Finn is easier to scream than Matt.
Are you guys factoring this, or are you distracting yourselves?
Anna distracted me, I mean Baron
God
distracted
forbid
me.
I can't breathe.
Matt,
Yes?
so you said I want to try 6x and x because 3 and 2 won't work?
Yes.
I think you are guessing rather than trying things. What
No.
are the things that you would try
I think I would
to
just,
see if 3 and 2 could work before you dismiss it and say, I don't want to try?
or I would use 6x squared. You know what I mean? Minus 3x.
Yeah, so this is 6x squared. And then what do I need these things to be? Like what signs do I need?
You need a 1 minus.
And then a positive.
Right? Or no, you
Two
need them
minus.
both,
These-
both minus.
They have to be both pluses or both
It's 3 and
minuses,
2.
So
right?
both minus, because you need them
It's
to.
3
And they
and
need
one.
to add them to this, so I do need minus and minus.
What adds to -7?
And then what factors of 2 could I use in these places?
Could you
It's
do-
either 2 or 1 or 1 or 2, right?
But
So it's
then-
either -1 -2 or -2 -1.
But that doesn't work.
I have a question. Could you
Yep.
technically do 3 and 1 because like 3 minus 1 is 2.
3 and 1 do not multiply together to give 2.
Okay.
No, you have to add 2.
9 minus 2 is technically 7. So like
I
Where's the 9?
the fact that they add together only gives me half the way there. I also need them to multiply together to give this term, and then I need them to add together to give this term. It has to be both. So if they fail on one or the other, that's not my choice. That's not my combination that's going to work.
It's -2 minus 1.
So what are the things that I need to try here? So this is back to 8th grade factoring,
2 and 1.
or whenever you had Algebra 1. What do I need? What are the possibilities here? I've figured out the sign, minus and minus, right? So what are the choices of what will work here, Jason?
So
16 divided by 8.
so they already will have like -2. We have 2 and 1. We have these two choice.
2 and 1, or Baron? What are my choices here?
1 and 2, -1, -2.
No. I chose the signs first so I could narrow down my list. So not
-1, -2.
all of the choices of factors that multiply together to give 2, because that would have been 1 and 2, 2 and 1, -1, -2, -2, -1. That's a lot of choices to think about. So I can narrow down my list by thinking about what signs I would like to have.
Mm-hmm.
And since they multiply together to give a positive and they add together to give a minus, that's minus minus,
Yeah.
right?
Mhm.
So now what are my choices?
You can do like -1, -2.
Is 1 or
You can do like fractions. Or
no.
Oh, -2, -1.
If I have to resort to fractions, I'm probably gonna just say forget it. I'll just use quadratic.
Okay.
Because this quadratic is always an option. I could have just started with quadratic, but if I take a look for a minute, maybe it's easier to factor.
I don't think the
If it's tough to factor, if I need to do square root of 2 and square root of 2, I'm just gonna
Do
say,
the quadratic formula.
I'll just do quadratic, it's gonna be easier. So, as far as integers go, what are my choices? And you're pretty much there.
-1, comma.
-1 and -2, -1 here, -2 here, or
-2,
-2, -1, let's just check.
How do those equal 7?
Because the -2, if it's 2, 1, if it's -2 times 2, -4, and then -3 times 1,
So
So
it'd
then
be
that's
-2,
approximately
1.
and that's
-7.
-7. Or if I did it reverse, if I checked it the other way, it'd be -2 minus 6.
So we got
That'd be
3x
-8.
minus 2 times 2x minus 1
Yes,
times x minus
yes.
2.
Yes, right. And then now, what am I able to answer?
Oh, then you could do the zero product property.
Yeah, I'll split them up using zero product property. -1, and then I still had an x minus 2 from before. And then what's my property called, Anna?
Zero product property.
Zero
Theorem.
product
Or is it a postulate?
property. I don't know.
Because theorems are proven and postulates aren't, right? Is that what the difference was? The postulates were,
are like.
Postulate's like your basic assumption.
and then theorems are like actually proven.
Theorems are proven, and then corollaries are like
Second.
offshoots, like sort of results that.
So would this be kind of a theorem?
So zero product property, I've only seen it referred to. I have not seen it proven, so I don't know if it's a theorem. It's just, for me, it's a logical way of thinking about it. So I know that, like, what's the form of zero product property when I have three things like this?
A times B times C equals
A, B, C now instead of A, B equals 0. And then logically, what does this have? What has to be true here?
A equals 0, B equals 0, or C equals 0.
Well, at least one of them has to be zero.
Yeah.
Well, we don't know.
So this is a logical OR, meaning if you know how logical ORs work, it's okay if they're both true.
Definitely not.
So if I need like to qualify for state funding, let's say, I have to have a freshman or a sophomore in my math class. They wouldn't disqualify me because I had both. So that kind of logical OR means if I have a freshman in the class, I'm good. If I have a sophomore in the class, I'm good. If I have one of each, I'm good. If I have multiples of each, I'm also good.
Is
So that's the
true?
kind of OR. That's a logical OR, huh?
Is that
How was the
true?
robotics thing?
Sorry?
How was your robotics competition?
We won 2 out of our 9 matches.
A win is a win.
We didn't get last place.
What place did you get?
51 out of
51.
57.
You know what? That's
That's
pretty
not
good.
bad.
Who got first?
Ex Machina, I think.
Wait,
Yeah.
how
X
do
minus
CSS there?
robotics like work?
It's a nerd joke.
It's a competition
Was
using
CSS
Vex
there?
How
robots.
do you not know X Machina?
Wait, do you like, do the robots
I
fight
don't
each other, or,
recall
like,
them being there.
is it like how ingenuitive it is, or like how good they are at fighting each other?
So sometime when we have time, I'll show you like the game that we played, and I can also show you a video of our match
Do
too.
they like
Actually,
fight? Do the
I have
robots
that.
just like kind of?
So they're
No, I actually wanna see
like
the
picking
house.
up objects and trying to score them. But by the time we got to the competition this weekend or on Monday and Tuesday,
Yeah, basically
these
all
were like
five.
really advanced. So you like your robot will go and pick up the ball or whatever and then deliver it to the goal area, and then some other competitor will come by and they'll have like a little claw on there and it'll just like rip all of the balls of your color out of there. It's like it was pretty fast paced and pretty different from the competitions that we've been having all
So was
semester.
this like a state competition, like a high
it's
level?
like a-
one?
This was at the Broadmoor, and it had people from all around the state. It had people from other states. People came from California. People came from Canada.
Oh,
This
out of your
Broadmoor
league.
has been very busy.
And
It's
it-
$505 to
That
register
big
your
money.
team.
Oh my
Takes
god.
me longer to get home.
Yo, it takes me longer to get
Wait,
to
I
school.
want to see the video.
Not wait.
Okay, I'll show you. I'll show you at the end if we have
That
time.
What they
Broadmoor
always
has been
do-
so
All right.
long.
They put little
Zero
signs.
product property. Shh. All right, zero product property. How do I apply this to this?
You
3x
set
minus
each
2.
term to
Set each term to 0,
yes.
and this will give me my roots. So what are my roots?
2x minus, 2x equals 1. 3x equals 2.
Mm-hmm. And then x equals?
3 over 2. Oh my god, wait. 2 over 3.
So if you can do this step in your head, feel free. If you need to do it more systematically, don't skip steps if it's going to cause you a problem. But you can skip steps if you think it through clearly. What's this root?
X equals 1 over 2.
1 over 2. What's this root?
X equals 2.
Right. So this graph would cross the x-axis where?
2/3, 1/2, 2.
So I have, let's do 1. Let's do 1/3, 2/3, 3/3.
Yeah, but then where's half?
1, 2, 3. So this would be 1. This would be 2. So x equals 2. X equals 1/2.
You have to do it by 6.
and x equals 2/3.
So there's a little move right there.
Where's the rest of the graph go? So here's my original f of x. What's the rest of the graph look like?
Up, down.
Yeah, so what's the left behavior?
Left behavior.
Falling to the left.
Right.
Falling to the left, and it never changes its mind again. So it falls to the left, and then what's it do to the right?
Rise.
It rises to the right. So what does it do in the middle?
It crosses the x-axis.
It crosses again,
Again.
and crosses. Yep.
Yep.
Right.
it
So
has
so
3 turning.
2.
No, it has 2.
Oh, I see.
what's the max that it even could have?
2.
2.
because
It's
There's
an
only
x.
3 points.
And minus
X
1.
because the x to the cube means it could have up to 2 turning points, and it in fact does have 2 turning points. So I can. Is this ever going to change its mind and become negative or turn down? Is this ever going to change its mind and turn positive
No.
or go up? No, it will never change its mind again. It only has 2 turning points, and the end behavior is this is going to rise forever.
Yeah, I thought.
And
that's
this is
what
gonna go toward
y-axis
negative
Was
for-
part of the line. That's what confused
That's
me.
what I saw. It was.
Oh, sorry, that's
Yeah.
that's my y-axis. That's
Yeah,
my
I see
x-axis. Right. So we can do a lot toward graphing once we figure this out. So this thing here was a factor because long division gave no remainder. But we can also do long division when there is a remainder. So as far as being able to factor things and say what my roots are, that would be this factor gives me no remainder. But let's look what happens if I do have a remainder. So divide.
Geometry.
What's wrong?
In that question.
What's wrong?
Oh no, we just saw Mr. Lee.
Geometry
Oh.
felt so hard, and now
Let's
I know,
do
we really
x
put that for
squared
granted.
plus 3x plus
I
5
couldn't tell if you were
over
triangles.
x plus 1. I want you to try this one. Shh.
Oh.
And then before you try it on your own, let's look back at our
Our steps.
11 divided by 8. When I got 8 goes into 11, and I said 0 here, 1 here, 8, 3. What did I do with my remainder 3?
You put it as a remainder, you can also do 3 8s.
So 8 divided by 11 equals what? Like I would say maybe the 4th grade way of writing this would be 1 remainder 3. The slightly upgraded version is 11 over 8 is 1 and 3/8. Where did the 3 come from?
The remainder.
That's the remainder in the numerator. Where'd the 8 come from?
The divisor.
Divisor in the denominator. So we're going to remember that. We're going to think about what we do with our remainder. What we do with our what's 1 called?
What?
What's 1 called in our mathy terms?
Quotient.
So we're going to do our quotient, and then there's sort of an implied plus here. Would you agree that 1 and 3/8 really literally means 1 plus 3/8?
Yes.
So there's an implied plus there. So I have quotient plus remainder over divisor. So let's do that, and you do the steps of dividing this. This is a what do you call this? What sort of function is this?
The fraction.
What is this whole thing called?
Fraction.
So it is a fraction. So this, I don't know if I've used this term with you before, but this is called a, oh, sorry, I rushed into it. This is a rational function. Why do we call it a rational function?
Because it's
A fraction.
rational.
Just like
No.
Just like the real solutions.
No,
Irrational.
no.
It's good.
What's an irrational number?
Oh, it does not exist.
Pi?
It's like
So
a
pi is an irrational number. What else is an irrational number? Square root of 2.
I.
Well, I is an imaginary.
I is a complex number.
Dang it, dude.
It's not a real rational number?
Rational number.
What's another irrational number?
7 but the square root of 7?
Square root of 7?
Square
Do you
root
know?
of 3.
Do you know e? Do you know the constant e?
Exponent.
It's the base of the natural logarithm. It is also an irrational number. What's
The base of
irrational
the
about these?
natural logarithm.
They have a
Yeah, I know
They
that,
are-
like, what?
Anish.
They are have an infinite decimal and never repeat. Infinite decimal.
And I cannot express these as a ratio of two integers.
Oh, yeah, that's right.
So if I can express is 0.25 a rational or irrational number?
rational.
Why?
It's one over 4.
Because I can express it in an integer over an integer. So it is a rational number. 0.25, even though there's decimals involved, I can do it that way. I can express it as a ratio. So you see ratio hidden in the word rational. So ratio means fraction, and these are irrational numbers because I cannot express them in terms of a ratio of two numbers. Just like this is a rational function because I can express this function in terms of a polynomial over a polynomial. So that's what makes this a rational function anyway. Sorry, that's just terminology, but you go ahead and set up long division
Okay.
and figure out what you got.
X plus
Practice
1.
your long division,
Oh,
polynomial long division.
Can you look at 9?
Ella's wrong.
So, so you're going to write, so just for the sake of notation, you're gonna write your original polynomial as f of x equals this, and then when you're done with your long division, you're gonna write f of x equals
Gotcha.
whatever your answer is, because these are equivalent. These are both f of x, these are both expressions of f of x.
Yes.
Did you get what I got?
Alright, so a little bit further. So x plus 1 is like, goes into this one time.
So off to the side, so I am demanding that you follow my procedure, because I think it's the way to keep yourself, your thinking clear and your results reliable, is your very first thing, once you set this up and your x plus 1 divided into whatever, you're gonna observe your place values, x squared, x constant. Off to the side in your scratch area, what goes over what to find out your first term?
X squared over x.
X squared y?
Over x.
Why x squared?
Because it's
That's
the
the
first.
It's the first term over,
The first
X.
term of the.
because it's the first term. So what's x squared over x?
X.
X.
Oh, and
First.
then you're gonna do x times x
And then
plus
x
1.
goes where? X goes where?
Under the x squared.
Oh.
Over
in
the
the-
3x.
It's not over the x
Under
squared.
the 3, yeah.
Over the,
Over the
over the 3x, because this column is reserved for x terms only.
Yeah.
So your result, x, goes over here, over 3, the 3x. And then,
And then do we plus 5 goes over, you go 5 over 1?
no.
No,
No,
it's-
after you write your x, what do you do
Yeah,
And then you
next?
do
Yeah.
x times x plus 1.
X times x plus 1, and then you're still going to observe your x squareds, x, and constant columns.
X times x over 1 would just be x.
X over 1.
Yeah,
X times
divided.
1. It's
When do
x
you,
times
when do
x
you ever
plus-
have over 1? It's always over x. I don't know what you're asking. Over, in your scratch area, it's always something over x.
Yeah.
And then it's something over x. Then you probably run out of terms.
Oh, I got it.
Observing your column, your places, like this is only x squared, this is only x, this is only constant, this helps you figure out when you're done and whatever you have left over is your remainder. Hope that made sense.
3x over x is just 3.
Cool, I got x plus 2, so
So you x plus 3.
Where did you multiply? You have to do step
On the
by
side,
step.
On the side.
No, you have to do step by step. It goes in your grid. I'm gonna do the first step and you tell me if you've done all these steps. Baron, what's my setup look like?
X plus 1 and then the division sign.
X plus 1 and then my little box.
Yep.
Wait,
And then what goes inside?
X squared plus 3x plus 5.
What am I checking for as I'm writing my...
the, like,
So like it's like 8 over 3 over 8. So
I'm looking for any gaps. I'm checking to see if I need any placeholders. Right, that's the correct setup. And then what's my first step, Baron?
Yeah, x squared divided by x.
X squared over x to the side, because this is the first term and the first term, right?
Then you get
And then I get x left over. Where does the x go?
over the 3x.
Over the 3x, because this is reserved for my x terms. This is my x term column. And then what do I do on my paper?
E times x squared by
I
x.
multiply this by,
X. So you get x squared plus x.
yeah, so I have to do it by the entire divisor, right?
Yeah.
So what's my x times x?
X squared plus x.
And where does x squared go?
Under the x squared.
Everything in this column has to be an x squared term.
What actually-
And then where's the plus x go?
Or under the 3x.
Under the 3x?
And then
'Cause-
we minus them, right? Or
and
subtract.
then how do I subtract them?
You distribute the negative.
Right. So to distribute it, I first have to write parentheses. Baron, don't forget about parentheses. And this part goes under here.
Mhm.
I do this step here because this allows me to subtract everything. What do I do after I do parentheses?
Then you subtract. and
I
then
subtract.
2x plus 5. Right.
Right, but I want you to go step by step. Write parentheses, write a minus sign, and then distribute your minus sign. So when I distribute it, what do I get?
Negative x squared.
Negative x squared, and then
Minus x.
minus x as well. And then when I add these together, what do I get?
Negative x squared plus x. Minus x.
So what do I get when I add this column together?
You get 2x plus
That's 0, and then this column is
2x.
2x, and then I have to bring down my next term.
Yeah.
Plus 5.
And
Okay.
then we do that again, right?
And do it again. And then what does it look like this time?
Now we do 2x divided by x.
2x, because it's the first term divided by the first term. You guys are so good at this. And that gives you what?
2
Where does my 2 go?
in the 5 column.
In the constants column, yes.
And then you get.
Is that
2x.
plus or minus 2?
Plus.
It's plus, right? It's a positive number. So I do plus 2. And then now what?
When you multiply by x plus 1.
Multiply this 2 by x plus 1. And that gives me what?
2x plus 2.
2x plus 2.
And then you put parentheses and make it a negative.
Right,
Then you minus. And then you get
right.
3.
Get 3. And because I've observed my columns, I know that I don't have any more places that I can fill up. So this is kind of like a decimal in regular long division. This is like the extra stuff. So I'm going to stop here because I don't have any more space to write stuff. So this becomes my what?
Remainder.
Remainder. So in 4th grade, if we were doing polynomial long division, I would say this polynomial divided by my divisor gave this quotient remainder 3. But we're not going to do it that way. We're not going to take a year to do remainder 3. Instead, I'm going to do what?
Divided by x plus 1.
That's so good. That's so good.
Okay.
Yay there.
Give yourself a high five.
Is that awful high five?
I'd like to forget.
So can I write my updated expression from my f of x now based on this? What do I say?
You did it, yeah.
What is my
F of x equals x plus 1.
where did the x plus 1 come from?
The
The divisor times
x plus 2.
where did the x plus 2 come from?
Quotient.
My quotient. And then what do I do?
3 over x.
Plus remainder, right? How do I write my remainder?
It's the remainder.
Remainder is 3 over
X plus 1.
divisor.
And then can we zero product property it?
Zero product property does not look like this.
It does not look.
No, it does not look like that. So x plus 1 was not a factor of my original polynomial because I should have gotten a remainder 0. I can still use polynomial long division to, let's say, rewrite or simplify this this rational expression.
Wait, so are we multiplying x plus 1 times x plus 2?
Say it again.
Are we multiplying x plus 1 and x plus 2?
No. This is not a way of finding factors. So x plus 1 and x plus 2 are not factors of my original rational function. So this is not in service of finding factors. It would only be a factor if this thing gave us no remainder. Does that seem confusing or weird?
It's polynomial.
I am not factoring this polynomial. These are not factors, right? This is a term and this is another term, and I don't have a zero product property that includes addition or subtraction. All right, let's do another example.
So that is the answer to the problem.
Yes,
Mr. Neal, do you have tissues?
I do.
He's quite illegible.
Oh, I see. Also, may I go to the restroom?
You may. But first you have to divide x squared, x cubed minus 1. Just kidding. X cubed minus 1. Let's just say, I'm just going to give it to you in the terms of a polynomial.
Is this the we're still doing the,
Sorry?
is this synthetic or we're doing?
We haven't started synthetic.
Okay, gotcha.
We're still doing long division. So I want you to do long division. But I want to talk about the setup first. Math, what's my setup look like?
X minus 1 and then that funny little.
And then the box?
Thing, yep,
And
then x
cubed plus
Wait. Matt, what's my setup look like?
Apparently x cubed plus 0 minus 1.
0x.
0x minus 1.
No.
No.
Patrick, you liar.
I didn't get to finish it.
Try it again, Patrick.
Well, maybe.
So it would.
Wait. Sorry.
God damn it.
Jesus.
So what am I doing when I'm setting these things up?
Prodigal son returns.
Apologies, I was in Lama's. I'm so sorry.
What am I doing when I'm setting up this long division?
We need x squared too. 0x squared.
So I'm going to observe what?
You have to have all of, like,
Like each column is a what? So it's kind of like place value in like a decimal number.
X
It
cubed plus.
might be thousands place, hundreds place, tens place, ones place.
Each column is the exponent.
Is its own power. So this column only allows x cubed stuff.
So is the next one 0x squared?
Yeah, so I'm not ready to write my minus 1.
So
you
plus
do
0x
plus
squared.
Plus 0x squared.
Plus 0x.
Plus
minus
0x minus 1. So as many placeholders as I need, I'm going to fill them in because I need a cubed column, I need a squared column, I need a x column, I need a constant column. I have to maintain those places to make my technique come out correctly. So yes, so Patrick, even though I interrupted you like 3 times, I think you were going to say plus 0x squared, is that right?
yes,
Plus
0x.
0x minus 1. So as many placeholders as I need. I'm going to fill in as many placeholders as I need. All right, you continue from there. We got the curse word on the recording, by the way.
Just.
Trust me, that's not a curse word. Oh, he interrupted me like five times in a row, and finally I got it back.
I mean, to be fair, I was asking him, so I only feel so bad about it.
I wouldn't feel super bad about it.
Oh. What's that mean?
I wouldn't feel too bad about it, Mr. Chair.
I really don't. So, Anna, what we're doing is we're dividing this one out, but as we're setting this up, we are very carefully making sure that I have an x squared and an x column, even though this
Yes.
polynomial, this part of it does not have
I see.
those places.
squared
So
is
we're doing our placeholders.
Oh, wow.
So did we find out that this is a factor of my rational function?
Yeah.
Why do you say it's a factor?
Because it would, like, when you write f of x, it would be like x minus 1, and then whatever your answer is a slash, it doesn't have a remainder?
Doesn't have a remainder. That's my
Okay.
test right there. If it doesn't have a remainder, it's a factor. If there's a remainder, then it wasn't a factor.
Oh my god. So if I do x divided by x.
So is everybody
I'm almost done.
able to? Okay.
So I've got an x minus 1.
I think I have it. Is it x squared plus x plus 1?
Is this my expression for f of x?
Mm-hmm.
Times x minus 1.
Oh, times x minus 1.
And does this seem like is this a reasonable result?
Mm-hmm.
Yep.
Because that's just x plus 1 squared.
Right. So when I multiply this out, I'm gonna get an x cubed term back. All right, last one.
Oh my god. I just
Last one.
messed up my paper.
After this, can we see the robot videos?
Please, I really want to see that. That looks very interesting.
Oh, that was horrible, actually.
So we add an x term for this one, like a 0x.
Right. So as I'm setting this up, I'm carefully watching that I've got an x cubed term, an x squared term. I'm missing an x term, and I've got a constant term.
Oh yeah, I know what to do.
You know what to do?
Oh yeah.
Is it plus 0x? Or is it minus 0x?
For the placeholder, you might as well say plus 0x. Doesn't really matter. So I suppose you could even do it this way, as long as you're realizing that that's, to me, it's easier to write a plus 0x because you might have to drop it down, you might have to subtract things from it.
Uh-oh. Did everybody else get 0 plus 0x?
0 plus 0x.
No, not the end, the first step.
All right, so let's do it.
Yeah, the first step you get just 0.
Is this my setup?
Mm-hmm.
So what's my first thing that I do over here? My scratch area.
Divided by x.
X cubed is the first term divided by x gives me.
X squared. So
Where does that go?
The x
above the
squared.
2x squared.
Right. And then what do I do?
And then x squared times x minus 2.
Right, gives me.
X cubed
Where does that
minus
go?
2x squared, but then it's negative x cubed plus 2x squared, so it's under there.
Sorry, say it again?
Negative x squared plus 2x squared, or negative x cubed plus 2x squared.
Let me just do one thing at a time. I'm still multiplying,
Oh, okay, x cubed minus 2x squared.
and that goes here,
Yep.
So
And-
put in parentheses,
And then you
put a
gotta
minus
multiply
around
it.
it.
and then I put a parentheses, and I put a minus, and then I distribute my minus sign.
Yep, and then you get 0
Yeah,
X squared.
plus 0x.
yeah.
Uh-oh, we have a
So I get
problem.
0x squared plus 0x. So how many times does, what do I do over here?
You just put a
Plus
0.
0.
So literally, what do I do for my next step over here?
I have no idea.
0 divided by x minus
What's
2,
my first term here?
which is 0.
What's my first term?
0.
0x squared.
0x squared. And then what's my first term here?
X.
X. So
What's the value of this?
0x.
It's 0, or 0x, yeah. So where do I put that?
Put the 0x up there.
The
Yeah.
X column.
Right. And then 0 is 0,
0.
and then minus.
Point
Would you get 2x or 20x or just 0x?
minus.
0x.
It's 0x times 0x. Right?
So 0x minus 9.
Yeah.
You get
So
2
it's just
0x.
negative, negative 9 over x minus 2.
Alright, so you get 0x, right?
Yeah, I have a question.
Hey,
Didn't you say last class we would get a super cool, easier method?
We're gonna do it.
we're heading there.
Yeah.
We're on the path.
Wait, so you get negative 9 and then what?
And
And
then
you do the little thing we
you
did.
do the like multiplication.
Yeah. So this is, yeah.
Wait.
Oh,
Multiplication.
sorry.
How many times? So this is kind of like when I'm trying to cram 8 into 11. How many times does 8 go into 1?
0.
0. How many times does x minus 2 go into minus 9?
0.
Yeah, the like leading terms is it's not going to give you anything. So I'm just going to end up with, what's my new f of x?
F of x equals x minus 2 times x squared, and then minus 9 over x minus 2.
Right.
Couldn't you just do x squared parentheses x minus 2 and then minus?
Yeah. So when I'm rewriting this, I could do it this way. It might look nicer. All right. So long division of polynomials handles pretty much anything you want. So what makes this a rational function? What makes this a rational function?
It can be represented by a polynomial over
A polynomial over a polynomial. Polynomial is just terms and terms. So that's a rational function. So long division handles all rational functions. So if I said divide, so let me just double check that I wrote this right. Minus 5x squared minus 2 plus 3x plus 2x to the 4th over 2x minus 3 plus x squared. Yes, I wrote that down correctly. All right, you set this up. And then we'll go through the steps together, make sure we know how to do something crazy like this.
Maybe like put it in like standard form.
So
General form.
it's really important to my process here that I observe all of the steps that I'm supposed to do. So I need my columns to start with the highest
So
power.
you need, like,
I need to observe placeholders.
Is this still long division?
This is still polynomial long division because I'm showing you a crazy example of you could divide any polynomial by any polynomial using long division. My super cool shortcut is not going to work for anything divided by anything. It's only a special case. The shortcut only works for a special case.
did I do it?
Yes, indeed. You should check.
Did I set it right? Wait.
Yes, indeed.
Okay, I don't know how to solve the problem.
Just like the same.
Well, you kind of do.
It's just a
Yeah,
lot
you
more
did that
work.
I can't.
You do,
It's just
because what are the important things that we're doing? We're observing place value,
and then
x to the fourth column, x cubed column. What's my very first step once I do that? Oh, in my
the
scratch
sum
area?
of the like the you do x to or x to the thing.
So I do the what term divided by the what term?
First.
The
First term divided by first term. That's all I'm doing on my scratch area to the side. So you know how to do all these steps. All the steps apply. So I'm going to set this up and you tell me if I do this right, if I make a mistake.
Where's the divide sign?
I haven't written it yet.
Oh, my bad. Is it, are we doing 2x to the fourth divided by x squared plus 2x, or just, no, just x squared?
Sorry?
Nothing,
Did I make a mistake?
no,
And what do I do in my scratch area?
no idea.
Yes, you do.
2x to the fourth divided by x squared,
Why?
because it's the first term.
First term divided by?
First term.
Yeah, you don't say you don't know what to do. You totally do. 2x to the fourth over x squared gives me what?
2x squared
2x squared. Good job. Where does that go?
over 5x squared.
It must go in the x squared column. That's the only thing that's allowed in this column. So I've got 2x squared. And then what do I do with that?
Then you gotta multiply that by the x squared.
By the whole thing, right? That gives me what?
2x to the fourth.
Where's that go?
Wait. What?
Where does that, where does, yes, 2x squared times x squared gives me 2x to the fourth. Where does that, where do I write that?
Under 2x to the fourth.
Right, it has to go in the x to the fourth column. 2x to the fourth, and then,
Plus 4x cubed
and that goes in the x cubed column, right?
minus 6x squared.
Plus 4x cubed minus,
6x squared. And then all the signs flip.
and then all the signs flip, because I'm going to write parentheses, I'm going to write a minus, I'm going to distribute my minus. All good so far? What do I get when I add these together?
No to the fourth.
Yep, it's 0 here, which we were hoping for.
And then negative 4.
Negative 4x cubed.
Yeah. And then positive x squared.
Plus x squared. Right.
And
And I'm going to need to drop down a term, right?
then we do. It's rough.
The answer is just real long.
And then what do I get? What do I get for the
Negative 4x cubed divided by x squared.
x squared? That gives me
Negative 4x. Oh wait, hold on.
where does that minus 4x go?
Oh, in the x.
In the x column, so it's minus 4x.
Yeah.
I have an answer.
What do I do with it?
Wait,
That's right, but I haven't.
What do I do with my minus 4x?
wait, hold on, I'm doing it. Alright, multiply by x squared plus 2x.
Mm-hmm. It gives me
Negative 4x cubed minus 8x squared plus 12x.
and then what do I do?
You gotta put it in the columns, and then you gotta flip the signs.
I flip the signs.
So then you get 9x squared minus 9x.
The 0 here, as I was hoping, 9x squared minus 9x. Nice. Minus 2, right?
No, I have to do that again, yeah,
Yeah. And then what do I do over here to the side?
same thing.
Same thing. What do I write? Baron, what do I write?
What?
I'm over here in my scratch area.
Oh, I got something different.
Do you do 9x squared?
9x squared
X squared.
divided by x squared gives me
9.
9. I was hoping for a constant, right?
Yeah.
So that's plus or minus 9.
Plus.
That's plus 9. And then I can multiply through.
I thought it was minus 8x squared.
Minus 8.
Not
Did you write parentheses and flip your signs?
Yeah.
Because I got minus 8x
I think I forgot
times
the sign.
times 2x. So I recommend that you follow this procedure carefully, because if you try to do any of these steps in your head, you will flip a sign. You will make
What's
a math error.
27. I got negative 27 x plus 25.
Yes.
Wow, I did that
wrong.
Wait, what did you get, Mom?
Hold on, so then it's
So close.
f of x
Negative
equals
27x
0
squared
x squared
the
minus
remainder.
4x plus 9.
X squared plus 2x minus 3.
Did you get minus 27x plus 25?
Yes.
And I'm out of spaces here.
Mhm.
So I'm gonna declare that my remainder. So I'm gonna say my f of x now is what?
2x squared minus 4x plus 9, and then you have negative 27
Wait.
x.
Wait.
Wait, I low-key did it.
Wait.
This is monumental.
So Matt,
I think I did it.
I
Did you feel like
prefer
did it?
I prefer if you don't forget your divisor by writing it first. Write your divisor first so you don't forget it. And my new f of x is my divisor times my quotient plus my remainder.
Really think I should have said there.
I low-key understand. This is monumental. This is crazy.
So I have x squared plus 2x minus 3, because that's my divisor, times what?
2x squared minus 4x plus 9.
2x squared minus 4x plus 9,
Yep.
and then,
And then negative 27x.
oh, wait. Tell me exactly what to write.
Minus 27x plus 25 over the divisor.
That's literally what I was about to say.
So my remainder is going to be a rational function. My rational function is, remember, it's divisor times quotient plus my remainder. My remainder has a minus sign in it. This should not cause me problems. I should literally write plus here, and then a bar for division, and then put my entire remainder in the numerator and my entire divisor in the denominator, because the way you described it, it looked like you were setting me up to say minus something. It's not really. Only this term is minus. So because I'm going to write this in a very systematic way, I'm going to write divisor
I understand.
times quotient, and then I'm going to say plus my remainder.
Can we watch the robotics videos
Now,
for our last 2
my
minutes?
remainder. What's my remainder?
Negative 27x plus 25.
In the numerator, right?
Over x squared plus 2x minus 3.
Yes.
Oh, yeah.
Mr. Diddle, I got the answer.
Me too. Before you did. Isn't that insane?
I got the answer, but the answer was
This is
wrong
like-
because I messed up a sign.
Okay, so we've done all of the polynomial long division that we need to do right now. Next time, synthetic division.
So the 3 point.
3.3 is not done.
Is it even close to done?
So the 3.3 is not due tomorrow.
Is it even close to done?
Thank you, Mr. Diddle.
I'm going to stop the recording right now.
Bye, Finn.
Bye, Finn.